we're going to use a problem from your past to make kind of a jump into what are called parametric equations. So a diver jumps off a 3, it should be meter, but I'm going to say it's approximately 9 feet, okay, with an initial velocity of 20 feet per second. An equation that models the height of this is given by h of t equals negative 16t squared plus 20 plus 9. Just some physics reminders about the coefficients. Of course, the 9 represents the initial height. This represents initial velocity. This represents the coefficient for gravity in the English system. Now, if you think about h prime of course is negative 32t plus 20. Well, h prime is velocity. At time 0, all that would be left is 20. That's why that's the initial velocity. So, you could think about it that way. How long will it take the diver to hit the water? Well, certainly there are lots of ways we could do this. We could use quadratic formula. I just pulled up a graph, and said, oh, it's about 1.6. Like I said, this is an old problem. I know you know how to do this, and we should get more decimals and make it more exact, but I want to get through this to get to the new stuff. The maximum height, well, we say, oh my gosh, it's up here somewhere. It looks like it's over 15 feet, but under 16 feet, maybe approximately 15 point blah, blah, blah. And you could find that, and you could use the derivative, set equal to 0, to find when the max is. Finally, how far from the board is the diver when he or she hits? Well, we don't know. Okay, this is the point of this. We don't know. A lot of people will look at this and say, well, okay, it times off. It gets up to 16 feet, comes down, and oh, it's 1.6 feet. Well, remember, this axis, the x-axis, or in our case, the t-axis, represents time. So we have no way of knowing how far from the board the diver hits. We have been given a vertical component here. Height. We know how far off the water the diver is, but we have no idea of the horizontal component, how far from the board the diver is. A lot of people mistakenly look at this graph and think that this is the diver's path. It's not. It is just a model of height. So now the question is, how can we model the path? Well, look at this problem. It looks very similar to the one we just did. I've just added one thing. I added a horizontal velocity. So now I've added a horizontal component. So now I can answer this question. The fact that it took approximately 1.6 seconds to hit the water, I can now say, well, how far away from the board was it at 1.6? I can just evaluate that. Okay, so 1.5 multiplied by 1.6. We have to be given two components to really track the path. This is a parametric equation. A parametric equation is one that gives us two components, a horizontal and a vertical, an x component and a y component, both as a function of another variable, in our case, time. So at any point now, I should be able to tell you the time, and you can tell me how far off the board, or how far off the water the diver is, and how far from the board the diver is. And it seems like a really simple idea, and in fact it is. It makes for some really simple math, but it's something that you haven't really had to think about before. Let me talk about how we could do this on our calculator. Okay, now I did this in screen cap, so hopefully you can see it okay. The first thing you're going to need to do is, and you might want to do this right now in your calculator, go to mode and change yourself from function to parametric. Okay, it's the second one in. You've already changed yourself to polar before, so we're in parametric. Then when you go to y equals, when you press the y equals key, you no longer get a y equals, you get this. x1 of t and y1 of t, and you can type in your two components that make up the one equation. You remember that your variable button that we've always used it as x, but when we were doing polars we had the theta. The T is on the same button. And this goes along with the modes. You know, function is X, parametric is T, polar is theta, sequence is N. So it goes right in order. You know, function, parametric, polar, sequence. So that's where we would get our variables from. After that, you go to window, and you'll notice some new things on your window feature. And mainly, you know, you'll still have your X-min, X-max, X-scale, but you have this new T. This is saying it's going to plot X and Y as always, but it wants to know how many times do you want to evaluate the two components for T. Well, for this one I set it at a T of 0 because of course we're starting at time 0, and knowing that the diver hit at 1.6, I didn't feel the need to go very high here. This T step, this is the default setting, and I'm going to leave it as that. I know we talked about that with polars, and I'll come back to that in a second. Over here, I scrolled down in the window. This is what I set my X min max at, and now here's the graph. So you look and you say, okay, so at time 1.6, the diver is maybe 2.3 units away from the board and hitting the water. This is actually the graph of the path of the diver. Okay, so it's kind of a neat thing, parametrics, to be able to actually map something's path. We've never been able to do that. We've only been able to map how high it is off the ground or how far you threw it or something, but never both at the same time. Now, I went back and I changed my T. Okay, in this case, T was 1. So what you see is that, or my T step, my T step was 1. And what you'll see when you do the T step is T step tells how often you want to evaluate. So this is saying, well, every 0.13 units I'm going to evaluate and evaluate and evaluate and plot those points. So time 0 is here, time 1 is here, and time 2 is down here already. And all it will do is connect those. So the smaller your T step, of course, the more accurate your graph is going to look, but it also takes longer to graph. You know, if you did a T step of 1/1000th, the path would look really smooth, but it would just slowly graph it. It would take forever. That's why I usually leave it as the default. It gives you a nice smooth graph. You know, it's set to look good on the pixels you've got on your calculator, and then you know exactly what the graph looks like. Okay, so these two things are the same graph, just with different T steps. All right, that's all I wanted to talk about in this video, was why we need parametrics and how we can do them on a calculator. The next video we'll talk about actually some kind of pre-calculus skills we're going to need to be able to do calculus with these equations.